All right. So think back, not to last chapter, but the chapter before. Back to chapter 4. What were we talking about in chapter 4? Congruency. And we were talking about, in particular, how segments are going to be congruent to each other. Now, there's two types of congruencies that we care about in geometry. We care about when two segments are congruent to each other, and we care about when two angles are congruent to each other. Now, you might say, well, what about triangles? Don't we care about when triangles are congruent to each other? Do we? Do we care if two triangles are congruent? Yeah, that's not a segment. That's not an angle. No, but it's a collection of segments and angles. And that's what we mean when we say two triangles are congruent, or any two polygons are congruent. We're somehow saying all their sides and all their angles are congruent. So all congruencies in geometry reduce to segments being congruent or angles being congruent. Chapter 4 was all about segments being congruent. Chapter 6 now is all about angles being congruent. Make sense? So that's a big picture where we're at. So I'm going to I rewrote out the postulates that we introduced in chapter 4 about congruence. And then here's going to be our ones for angles. And you're going to see how they're almost saying identical things. So let's remind ourselves of the postulates back from chapter 4. So what was our first postulate? Give it to me in high-level language. Our very first postulate about congruences. It's if I gave you some segment, here's some segment right there, and I gave you a line right here, and I say, I want you to give me a segment on this line congruent to this segment. You first have to ask me two questions. You have to say, where should I start? And I say, okay, pick a point, and I say, start right here. Then you say, okay, did you want me to create the segment over here or over here? Should I go this way and find a point so that this is the same big as that, or should I go this way and find a point so that this is the same length of that, right? So what was the postulate? The postulate says, given some segment AB and a point A prime on L. So here's L, here's some point A prime on L. Don't read into the fact that those two look parallel to each other. They're just a segment and a line. Now, the postulate was, on a particular side of A prime on the line, there's one and only one point B prime, such that this segment is congruent to your given segment. So if I gave you A prime, if we didn't have B prime there, if I gave you this line L and this point A prime, and I said, construct a segment congruent to this segment at A prime. You say, which side? Did you want me to use the point B prime over here, or did you want me to use the point B prime over here? And the point is that there's one and only one point on each side of A prime that gives you a segment congruent to your given segment. Does that make sense what I'm saying? Does it feel like I'm just repeating myself over and over again? Read it one more time. Given some segment AB and a point A prime on L, there exists a unique point B prime on either side of A prime, such that AB is congruent to A prime B prime. Good? Okay. Over here now, postulate group 5. What's our first postulate going to be? Instead of starting out with some segment that we're trying to create a congruent segment to, you start out with some angle A, and we're going to try and construct an angle congruent to angle A. Right? So given some angle, we're given now, instead of a point on a line, we're given a ray on a line. And our job is to construct an angle using this ray congruent to this angle. And notice that we can pick the angle up here or the angle down here. I can add a ray up here or I can add a ray down here to construct a congruent angle. Same way over here when I had a point, I could add a point over here or I could add a point over here to construct a congruent segment. So let's read out exactly what it says and hopefully that makes sense. Given a non-straight angle A and a ray R prime on L prime, so here's R prime on our line L prime, from some point A prime, there exists a unique ray S prime on either side of L prime, such that angle A is congruent to angle A prime. There's one and only one ray S prime I can find up here that makes this angle congruent to this angle, and there's one and only one ray S prime I can find down here that makes this angle congruent to this angle. So once I give you a ray, if I tell you now construct an angle congruent to some given angle, there's only one ray you can add on this side, and there's only one ray you can add on this side that satisfies that. That make sense? Yeah. Okay. What was our second postulate about equivalences? About congruences. Oh my goodness.
It's an equivalence relation.
It's an equivalence relation. Do that way too much. So I specified here, maybe make some note of this. We're using the same symbol, which is a little bit dangerous. And so you have to infer from context what we're talking about. Are we talking about angles being congruent or segments being congruent? It makes zero sense to write something like angle A is congruent to segment AB. That makes zero sense. Now we're really lazy as mathematicians, and we don't want to come up with a separate symbol for talking about angles being congruent, because it almost means the same thing. So technically, this means something different from this, but we're using identical symbols because we're being lazy. That make sense?
Yeah.
So, segment congruence is an equivalence relation. That was our postulate from chapter 4. What does that mean? Our first property is what?
Identity.
Not identity.
If something is congruent to itself.
Every segment is congruent to itself. We call it the reflexive property. Everything is identical to itself. Every segment, not identical. Every segment is congruent to itself. Make sense? That was one of the things you proved on your test. Ish. Not really, I guess. You just used it. Okay. So, first property is every segment is congruent with itself. Same with over here. Angle congruence is an equivalence relation. Every angle is congruent to itself. Next, what was our second one?
Symmetry.
The symmetric property. If AB is congruent to CD, then CD is congruent to AB. Not all relations are symmetric. Remind yourselves of, if A is less than B, does that mean that B is less than A in algebra?
No.
So it's only special relations that have these properties. Not all relations have these properties. Congruent happens to have these properties. So if AB is congruent to CD, then CD is congruent to AB. Similarly, if angle A is congruent to angle B is congruent to angle A. Next, what was our final one?
That's no.
What is it?
Associativity.
Not associativity. That's doing parentheses when you're doing algebra. It's called the transitive property. The transitive property. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. You thought about that as being the same height? It's kind of like congruence. If I'm the same height as Jack and Jack's the same height as Jill, I'm the same height as Jill. Transitive property. Similarly with triangles. If angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. All right, and then finally, our last two. What was our mnemonic device for remembering these?
Equals, subtract, equals, equals.
Right.
And
And equals.
added to equals or equals. Perfect. Equals subtracted from equals or equal, and equals added to equals or equals. We typically do the added one first. So that's what this is going to say. So if AB is congruent to A prime B prime, and BC is congruent to B prime C prime, then AC is congruent to A prime C prime. That's what this says. In other words, equals added to equals result in equals. That's the mnemonic, remember. And then similarly for this one, if AB is congruent to A prime B prime, and AC is congruent to A prime C prime, then
BC is congruent to B prime C.
perfect. So if the wholes are equal and the pieces you're subtracting are equal, then the result is equal. Or equal subtracted from equals or equal. That's the mnemonic we remember. None of this is actually talking about equality. It's just what we remember in our heads. This is going to say the exact same thing. So, if I know that angle A, little bit of notation. When you have a point out here labeled on an angle, then whatever that point's name is refers to the entire angle. So when I say angle A, that's referring to this. And I've got angle B marked there, sorry that's kind of small, and angle C marked there. Similarly, here's A prime, here's B prime, here's C prime. Can you see all that okay? Okay, so if I know that A is congruent to A prime, and I know that B is congruent to B prime, then what do I know?
C is congruent to C prime.
C is congruent to C prime. So equals, so I've got the wholes are equal and these pieces are equal. So when you subtract those away, the result is equal. So this still says equals subtracted from equals are equal. Right? Go ahead.
You have to rely on the picture to know that C and B are.
Thank you. Yes, it has to be the case. I didn't want to try and write this all out in words, what these angles have to look like. But you have to have that B is adjacent to C, and A is composed of the sides that B and C do not share.
Oh, okay.
And
That's how you would explain that in like a proof or something if you were trying to.
well, you can just reference this postulate directly, and you can expect me to understand what you're talking about. So I wouldn't expect you to say, observe that since we have B is adjacent to C and A is the angle composed of the sides that they don't share, and A prime is congruent to A, and B prime is congruent, or B prime is adjacent to C, and A prime is composed of the rays that B prime and C prime don't share, blah, blah, blah. It becomes a big mouthful. So I'm okay with you just referencing this directly based off of the picture you set up. Make sure you set up your picture correctly. But then people should be able to infer how you're using these. So good. That all makes sense? Okay, now this next one is going to say equals subtracted from equals or equals. Again, it's just going to subtract off a different piece. So it's going to say if A is congruent to A prime and C is congruent to C prime, then
B is congruent to B prime.
B is congruent to B prime. Perfect. And then finally, the last one says equals added to equals or equal. So if B is congruent to B prime and C is congruent to C prime, then
A is congruent to C.
perfect. And there you go. That's almost all we have one more postulate to add, but that's basically all the postulates we're adding for this chapter. Same idea, same thinking as before, right? Just angles instead of segments. So hopefully that helps the transition into this chapter a lot. Any questions so far before we start doing a couple proofs using these things? All right, let's jump into it then. So our first proof, if two angles are congruent, so are their supplements. What is the supplement of an angle? Remind ourselves of that. So I've got some angle here. Angle A, what's its supplement?
That's the part that
What do you know about supplementary angles?
they add to a straight angle.
They add up to 180 degrees, might be what you remember from school. Supplementary angles are angles next to each other where their opposite sides make a straight line. Or angles who add up to 180 degrees. That's perfect intuition for it. Good? So what are we trying to prove? I'm trying to prove that if A is congruent to A prime, then A's supplement is congruent to A prime's supplement. So I'm trying to prove if two angles are congruent, namely A and A prime, so are their supplements, namely B and B prime. That's going to be how I set my picture here. You with me so far?
Yeah.
Okay. Now, how am I going to do this? Oh, missed one more piece. Sorry, down here. And I even put an exclamation point, hoping I wouldn't forget it. You guys can't let me miss exclamation points. This was supposed to be added onto here. Notice that this says, given a non-straight angle A. Right?
Yeah.
One more piece of it is also all straight angles are congruent.
That's a postulate.
Yes. You have to have that as a postulate. Euclid used all right angles are congruent, uses that to prove that all straight angles are congruent. You could just as easily take all straight angles are congruent and prove all right angles are congruent. So all straight angles are congruent to each other. So all lines are congruent to each other in terms of angles. That makes sense? Okay, now we're ready to jump into this. So how am I going to prove that B is congruent to B prime? So imagine I know that A is congruent to A prime. I need to prove that B is congruent to B prime. How am I going to do that?
By finding another angle that's congruent to another angle on top.
Overthinking it.
Or makes it
What do I know about angle L and angle L prime?
that they're congruent because they're straight.
That they're congruent because they're straight. So I know that L is congruent to L prime, and I know that A is congruent to A prime.
use
It's
the postulate.
to be
Using,
postulate.
yeah, using the fact that equals subtracted from equals are equal. Oh, is that what you were saying?
Yeah, so you find another angle that's congruent on both. You found the straight angle that's congruent.
Oh, that's what you were saying. I thought you were looking for a third angle and then trying to use transit property. I see now. Yes. So that's the big idea. So you already have the big idea in your head. I know L is congruent to L prime. I know A is congruent to A prime. And so using the fact that equals subtracted from equals are equal, I get B is congruent to B prime. Or using postulate, whichever one it is. I think it's this one. So using postulate V-1. I'm okay with you just calling this postulate V-3, and I can tell when you're doing adding together they're the same or subtracting together they're the same. You don't need to say using postulate V-3-2. That's a bit excessive. Okay, so now let's jump into the proof now that you can pretty much see how to do it. So let angle A be congruent to angle A prime. What was I trying to show? If two angles are congruent, so are their supplements. So what should the first line of my proof be? Let two angles be congruent. I'm calling them A and A prime. So let angle A be congruent to angle A prime. There's my two congruent angles. Next, let angle B and angle B prime be the supplement of angle A and A prime on lines L and L prime respectively. Not respectfully, but respectively. Okay. So now I've set up our picture, right? Okay. So now, observe that angle L is congruent to angle L prime. How do I know that?
Because all straight angles are congruent.
All straight angles are congruent, so that's V-1. This was supposed to be part of 1 up here. This was, if it's a not straight angle, here's the case, and if it's a straight angle, here's the case. That's how it was supposed to be. So, sorry. I realized after I'd written a lot that I forgot to add that. Okay, so I know that from V-1. And I know angle A is congruent to angle A prime. How do I know that? That was given information. Therefore, angle B is congruent to angle B prime. How do I know that? By V-3. Equals subtracted from equals are equal. Good? Pretty simple proof. Good one for a test. Yeah, all right. If the kids say yes, that's a good one for a test. That's how I know that they understand it. Okay, next one. Vertical angles are congruent. That's what we're trying to prove. Vertical angles are congruent. What are vertical angles? Tell me like I'm a 6th grader. What are vertical angles?
Angles that are
Opposite each other.
on the other side of each
Draw
other.
2 lines. Draw 2 lines and they're the angles.
Perfect. Make 2 lines intersect. And then vertical angles are 2 angles opposite each other. So either those 2 or those 2. Okay, so that's vertical angles. So I'm trying to prove vertical angles are congruent. So what do I need to start with? I need to start by intersecting 2 lines and creating 2 vertical angles. So let angle A and A prime be vertical angles composed of lines L and L prime. Setting up my picture here. Forget B for a second. Okay, so I've got this set up. Now I'm trying to prove that A is congruent to A prime, right?
Yeah.
Now let's look at one of these angles. B could have been this or this. Let's look at one of these angles adjacent to these 2 angles. Just one of the other angles. Call it B. Now, what is B in relation to A?
Jason?
A straight angle.
It's a supplementary angle.
Supplementary to make
I can tell that's what you're thinking, right? These 2 together create a,
straight.
so this is the supplement of this. Furthermore, these 2 together create a
Straight.
straight angle, so this is the supplement of this. Now I'm going to say that a little bit different. A is B's supplement, and A prime is B's supplement. Right? And what did we prove up here?
That the supplements to your angles are congruent.
Right, if 2 angles are congruent, so are their supplements. So, angle A is a supplement of angle B, and angle A prime is a supplement of angle B,
And everything's congruent to itself.
and angle B is congruent to itself. So since B is congruent to itself, then B's supplements are congruent to each other. You see the thinking there? If angles are congruent, so are their supplements. Since B is congruent to B, then B's supplement is congruent to B's supplement. Therefore, those angles are congruent. That's the thinking here. You feel like you got big picture grasp of what we're doing? And now just fill in the details. I had a teacher, he told me, before you try to prove something, make it almost obvious to you. Draw out the picture until it feels like it's almost obvious, then go about trying to prove it. Rather than just writing a line and getting stuck. Start drawing the picture and just play to the side. Do what you need to do to make it feel almost obvious. Then go through the work of proving it. So now that we've got our picture, we've got it almost obvious to us, let's just write it out. So let angle A and angle A prime be vertical angles composed of lines L and L prime. Let angle B be one of the angles adjacent to angle A and angle A prime. Doesn't matter if we chose that one or that one. Good so far? Observe that angle A and angle A prime are both supplements of angle B.
How is that? How do you know that? Like, is that part? What's the leap of logic there? How do you
What's the
know,
leap of logic there?
How do you know that they are supplements? I guess.
How do I know that B is a supplement of A?
Yeah.
You could have specified if you wanted. You could have said, observe that angle B is a supplement of A since their non-shared sides compose line L prime, and angle B is a supplement of angle A prime since their non-shared sides compose line L prime.
Okay.
You could have specified it out that much, but I don't think it's a leap for you to follow. Again, it's kind of frustrating when you're first getting into proofs. How much detail do you put in there? How much do you explain? And what's the right answer? Enough. Yeah, it's a terrible answer. So here's the thought experiment that is told to students. Put as much information in there as you think you need, as you think one of the students in the class would need to completely follow your proof. So you are writing a proof so that Alexandria could completely follow all your thinking and reproduce it herself as she needed to. If you've achieved that, you're good. That's what you should aim to do. And so your proofs naturally get lazier the more advanced you get in the field. And that's just understood. Those of you who say, I don't like that, what exactly is a proof? Come to Logic tomorrow night and we'll go over a rigorous proof, actually going through what exactly a proof is and no skipping details. Anyways, so we skip a little detail there. Observe that angle A and angle A prime are both supplements of angle B, and that angle B is congruent to angle B. How on earth do I know that angle B is congruent to angle B?
Because of your postulate. Number 2.
Right? That's from 5.2. I should have probably written 5.2 there. Although, stating, probably should. Okay. So then I know, since angle B is congruent to angle B, using Theorem 6.1, angle B supplement is congruent to angle B supplement. Therefore, angle A is congruent to angle A prime by Theorem 6.1. I could have added probably just a little bit more detail there, since angle A and angle A prime are the supplements of angle B. Good? Okay. Any questions on that proof before we move the camera and go to the next one? All right. We are flying through this material faster than I thought we would. Maybe these other proofs will be more of a holdup. I can see both those. Okay. First definition of the chapter now is going to be a right angle. What is a right angle? Tell it to me like I'm a 6th grader.
It's
90 degrees.
90 degrees, okay, but now we don't have degrees.
2 right angles added together create a straight angle.
2 right angles create a
Straight.
straight angle. That's one way to say it, so you're getting at something. So our definition of a right angle is, notice if this is a right angle, what's this angle over here?
A supplement.
Right angle.
Also a right angle. So I have supplementary angles that are congruent to each other. And that's going to be a right angle. What is a right angle? It's an angle congruent to its supplementary angle. Make sense? So a right angle is an angle that's congruent to its supplement. Okay. Now, our last postulate of the chapter. This is called the side angle side postulate. We will not refer to it as a side angle side postulate because unfortunately there's a side angle side postulate and a side angle side theorem. And usually when people refer to side angle side, they mean the side angle side theorem, not the side angle side postulate. We'll explain the difference between these two things. So even though it's called the side angle side postulate, when you reference this thing, use 5.4. And then when you reference this theorem, you can use side angle side and not have to remember the theorem name.
Gotcha.
Make sense?
Yep.
Okay. Now, what does the side angle side postulate tell us? First off, when I say side angle side, you probably heard it before. What does side angle side mean?
It means that if you have two triangles,
If two triangles have a side, an angle, and a side congruent, then the triangles are congruent. Right?
Yeah.
That's what we'll prove here. This postulate is what we need to prove this. So here's the postulate. It almost gives us all that. It just gives us slightly less information than that. So if triangle ABC and triangle A prime, B prime, C prime are such that they have AB congruent to A prime, B prime, a side congruent to a side. So AB is congruent to A prime, B prime. Angle A is congruent to angle A prime. And AC is congruent to A prime, C prime. So notice I know two sides are congruent, and the angle using those two sides are congruent. This doesn't work if I know this side's congruent to this side congruent to this side, and this angle is congruent to this angle. It has to be the angle between the two sides. Order here matters. So if I've got the side congruent to the side, the angle congruent to the angle, and then the other side adjacent to that angle congruent to the other side adjacent to the other angle, then what do we know? The postulate tells us, then we know that B is congruent to B prime, angle B is congruent to angle B prime, and angle C is congruent to angle C prime. It does not tell us that this side is congruent to this side. We will prove that that's the case over in this theorem. And so the triangles are congruent. So it only gives us that the other two angles are congruent, the postulate.
why does it have to be postulate? You would prove that.
How you show that postulates are independent of each other will be a topic in logic. But the short answer is, provably, we cannot prove it from the given postulates. And that's something that you could possibly prove. How would you prove something like that? That'll be one of the topics of logic. How you can do this analysis of axiomatic systems. Okay. So that's what the postulate gives us. If I have two sides congruent and the angle between them congruent, then the other two angles are also congruent to each other. Side angle side postulate, which we will refer to as phi 4. We will not refer to it as side angle side. We'll reserve that for the theorem. Okay. Now definition. What's an isosceles triangle?
So a triangle where two sides,
It's a triangle where what?
two sides are the same.
Where two sides are the same. That's roughly what you say. Where this side is congruent to that side. So definition. A triangle is isosceles if two of its sides are congruent. Now definition has a little bit more. We call the two angles opposite the congruent sides the base angles. The angles opposite the congruent sides are called the base angles. So every isosceles triangle has a base. It makes sense to talk about the base of an isosceles triangle. Make sense? Question. Is an equilateral triangle an isosceles triangle?
Yep. Two sides are the same, right?
Three sides are the same.
Always.
If you have three sides the same, do you have two sides the same?
Yeah.
Yes. So an isosceles triangle, an equilateral triangle is a special case of an isosceles triangle. Good? All right. So now, we're going to prove an isosceles triangle's base angles are congruent. So if I've got some isosceles triangle here, then its base angles are congruent to each other. This angle is congruent to that angle. You with me?
Yep.
All right. How are we going to do this? This is one of the simplest proofs that always tricks up you guys very bad because it has a double labeling. So let's wrap our heads around this. What I'm going to do is, here is my triangle A, B, C, right? And I'm also going to call that triangle A prime, C prime, B prime. I'm labeling the exact same points with two different labels.
Okay.
You with me? Now, I'm going to redraw this triangle right here with just A, B, and C written. Just redraw it right there. So I know that that is congruent to that. Right? And now I'm going to redraw this triangle right here, but I just flip it as I draw it. So A prime, C prime, C prime, B prime, B prime. Same exact triangle, just flipped how I drew it. I just drew these two pictures to help your guys' intuition. The proof only needs what's up here. You with me? Okay. So I've got this triangle and this triangle. Notice that this side then is going to be the same length as this side. Right? This side is right here. This side is right here. Furthermore, I know that this side is the same big as this side. This side is right here. This side is right here. Now, they all happen to be the same size. That's congruent to that, is also congruent to that, is also congruent to that, right? But I'm just labeling it this way to help your intuition. And then finally, I know that angle A is congruent to angle A prime. Right? So now, by side angle side, I know that this angle is congruent to this angle, and this angle is congruent to this angle. You with me?
Yeah.
So I know angle B is congruent to angle B prime. Angle B is congruent to angle B prime. And so I know that these two base angles are the same big. Make sense? It's a very simple proof. I just noticed that ABC, triangle ABC, and triangle A prime, B prime, C prime have congruent angles by Postulate V-4, the side angle side postulate. So there's drawing it out. Let's go over the actual proof now. Very small proof. Let triangle ABC be isosceles with AB congruent to AC. So AB is congruent to AC. Let triangle A prime, C prime, B prime equal triangle ABC. Now this equals thing is a very strong statement. What does it mean to say two things are equal?
They're identical.
They are absolutely identical. When I say that triangle A prime, C prime, B prime is equal to triangle ABC, I am saying that A prime and A are the exact same point. I'm saying C prime and B are the exact same point. I'm saying B prime and C are the exact same point. It's a very strong statement. If I know that triangle A prime, C prime, B prime is equal to triangle ABC, do I know that it's equal to triangle BAC? Is this equal to this? Triangle BAC is the same triangle as ABC. Triangle BAC, that's right here. This is the same triangle as that, isn't it?
Yeah.
And this is equal to that. So this is equal to that. And the answer is no. These are two different ways of writing the same triangle. That's true. This is equal to that. It is not equal to this. Because A prime is not the same as B. So the order that you write these things in matters very much when you're naming your triangle. When we loosely say that this triangle is equal to this triangle, what we say is there is a way of labeling the points such that equality holds. When we say that this triangle is congruent to this triangle, what we mean is that there is a way of labeling their vertices so that the congruency holds. Order very much matters. You will get tripped up on this order thing early on. So, I say triangle A prime, C prime, D prime is equal to triangle ABC. That's relabeling A and A prime exact same point, B and C prime exact same point, B prime and C exact same point. Okay, now observe that AB is congruent to A prime, B prime. AB is congruent to A prime, B prime. How do I know that? How do I know AB is congruent to A prime, B prime?
An isosceles triangle.
Because it's an isosceles triangle. Or in other words, I already knew that AB was congruent to AC, and AC is the exact same segment as A prime, B prime. With me? So I know AB is congruent to A prime, B prime. I know angle A is congruent to angle A prime. And I know that AC is congruent to A prime, C prime. How do I know AC is congruent to A prime, C prime?
Because you renamed the points and now they're.
It's just from the relabeling of points. AC is congruent to A prime, C prime. AB is A prime, C prime. Identical. With me? So then,
Wait, how do you know that angle A and angle A prime are congruent?
because they're the exact same angle, reflexive property. Every angle is congruent with itself.
Because they are equal. That's why I used equivalence as a congruent for the triangle.
Okay. So then, angle B has to be congruent to angle B prime, and that's all we needed, but also angle C is congruent to angle C prime by postulate V-4. Samaria. Make sense?
Yeah.
Okay. Next definition. Midpoint. What is the midpoint of a segment? If I gave you some segment here, and I said find the midpoint, what's the midpoint?
Half a segment.
Half the segment, that's one way of saying it. How do I know if I found the midpoint here? What will happen if I found the midpoint? M.
If the two resulting segments are identical, well, not identical, congruent.
Congruent to each other. So, M is the midpoint of some segment AB if and only if M is between A and B and the segment AM is congruent to the segment MB. That's what it means to be the midpoint. Good? Okay. Now next, what does it mean for two triangles to be congruent to each other? What does it mean to say that triangle ABC is congruent to triangle EFG? Now order here matters. So when I said this triangle is congruent to this triangle, I'm saying that segment AB is congruent to segment EF. I'm saying that segment BC is congruent to segment FG. And I'm saying that segment AC is congruent to segment EG. And I'm saying that angle A is congruent to angle E, angle B is congruent to angle F, and angle C is congruent to angle G. You see how order very much matters there.
Yeah.
I am not saying that angle A is congruent to angle F. The only angle we know A is congruent to is E. The first angle here is congruent to the first angle here. The first segment listed here is congruent to the first segment listed there. All those orders matter. That make sense? Yeah. Okay. So now we're going to prove our side angle side theorem. I'm going to prove that if two triangles may be labeled, triangle ABC and triangle A prime B prime C prime, such that AB is congruent to A prime B prime, angle A is congruent to angle A prime, and AC is congruent to A prime C prime, then the two triangles are congruent. Let's draw a picture over here. So here's ABC. We start out with these two triangles. We label them ABC and A prime B prime C prime in such a way that this side is congruent to this side is congruent to this side, and this angle is congruent to this angle. So that's all we know so far, right? So I've got these two triangles. This side's congruent to this side, that angle is congruent to that angle, this side's congruent to this side.
Okay.
Now, by the side angle side postulate, by postulate V-4, I instantly know that this angle is congruent to this angle, and this angle is congruent to this angle.
Yep.
That's what it says. You with me? So all that remains to show is that segment BC is congruent to segment B prime C prime. If we can show that, then these two triangles are in fact congruent. So let's set up that much of the proof real quick. So let triangle ABC and triangle A prime B prime C prime such that AB is congruent to A prime B prime, angle A is congruent to angle A prime, and AC is congruent to A prime C prime. So then, angle B is congruent to angle B prime, and angle C is congruent to angle C prime by V-4, by the side angle side postulate. So got to there, that's setting up the picture that we have so far, except for this point D prime, right?
Yep.
So now, all we need to show is that this segment is congruent to this segment. That's the heart of the proof. So I'm going to pick some point D prime here. We'll say it here really quick. Let D prime be on B prime's side of C prime, such that CB is congruent to C prime D prime. So pick D prime here, such that this segment is congruent to that segment.
Okay.
Now I need to argue that D prime and B prime are in fact the same point, and then we're done. So I pick D prime such that C prime D prime is congruent to CB. Now to help us think, I just redrew this triangle down here. You with me? So I know that this side of this triangle is congruent to this side of this triangle, right? Good? So notice that this side is congruent to this side, this angle is congruent to this angle, and this side is congruent to this side. So then what do I know? What?
They're the same angle?
That they're the same angle?
Or the same?
That was the same angle.
A prime.
Then, this angle, this isn't really A prime. This angle is this angle right here, right? Then this angle has to be congruent to this angle. How do I know that?
Because that's how we set it
How
up.
do you know that?
What,
Let's set up again.
by your postulate.
Looking at these two triangles, I have this side and this side are congruent, right? I have this angle and this angle are congruent. And I have this side and this side are congruent. And so by postulate V-4, I know that this angle
Oh, gotcha.
has to be congruent to this angle, and this angle has to be congruent to this angle.
Okay.
Now I don't care that this angle is congruent to this angle, I'm just going to focus on the fact that this angle is congruent to this angle.
Okay.
So I know that this angle is congruent to this angle. This angle, drawn in this picture right here, is this angle.
Yep.
So this angle is congruent to this angle, and this angle is congruent to this angle. What does that mean? If I know that this angle is congruent to this angle, and I know that this angle is congruent to this angle, what do I know about these two angles?
They're both congruent.
They're both congruent, but furthermore, we know something stronger than that.
They're the same angle.
They have to be the same angle. How do I know that this angle and this angle have to be the same angle? Given a ray, there's one and only one ray on the same side, on a particular side of the line, such that it's congruent to some given angle. Both these angles are using the ray that goes through A prime, C prime.
I see.
And now we're constructing a second ray over here to make it congruent to this angle. But there's one and only one ray that does that.
So
And that's the ray that goes through A prime, B prime. So, D prime is on this angle's ray, so D prime has to be on the ray through A prime and B prime. So D prime is on this line, and D prime is on this line. Two lines intersect at how many points? One. And B prime is already the point that they intersect at. Obviously B prime is on the line through A prime, B prime, and obviously B prime is on the line through C prime, B prime. So D prime has to be on both those lines. And B prime is the only point on both those lines, so D prime is B prime. This is a tough proof to follow. There's a lot going on. And it's all just to prove that this side is congruent to that side. So take it from the top, let's run through it again, make sure everything makes sense. So, redrawing what we know. Get rid of that. Get rid of that. Shouldn't have used it one document. Okay, so from the start, I got two triangles, A, B, C, and A prime, B prime, C prime. And what do I know about those two triangles? I know that they have a side angle side congruent to a side angle side. Now, from our side angle side postulate, their other two angles have to be congruent to each other. All that remained to show is that this side was in fact the same big as this side. So I choose D prime. D prime is a point that we chose, such that this length here would be the same as this length here. That point to D prime. Redrawing our picture down here. So this segment here is the same long as that segment there. That's how we chose D prime. Now, if we can show that D prime is in fact the same point as B prime, then this side is the same long as that. So we're trying to show D prime and B prime are the same point. How do I know D prime and B prime are the same point? Well, I know D prime and B prime both lie on this line, all that remains to show is that D prime is also on this line up here. And if D prime is on both these lines, both those lines intersect at one and only one point, namely B prime. And so D prime is B prime. So that's what we're doing down here. So we redraw this triangle down here to help us think. And we know that by side, angle, side, side, angle, side, this triangle and this triangle have their other two angles congruent to each other. All we care about is this one. So this is congruent to that, and this angle is congruent to that angle. And so this angle and this angle have to be the same angle. And so D prime has to lie on this line. And so D prime is B prime. All right, let's read it through the actual proof now. And hopefully with that, it's enough to sink in. We'll just take it from the top. So let triangle ABC and A prime B prime C prime such that AB is congruent to A prime B prime, angle A is congruent to angle A prime, and angle AC, and AC is congruent to A prime C prime. So then we instantly know that angle B is congruent to angle B prime and angle C is congruent to angle C prime by postulate V-4, by our side angle side postulate. Let D prime on B prime side of C prime such that CB is congruent to C prime D prime. Such that CB is congruent to C prime D prime. Good so far? Now, since C prime D prime is congruent to CB, C prime D prime is congruent to CB, angle C prime is congruent to angle C prime is congruent to angle C, and C prime A prime is congruent to CA, C prime A prime congruent to CA. So side, side, angle, angle, side, side. Then angle DA prime C prime has to be congruent to angle A. D prime A prime C prime is this angle right here. So I know D prime A prime C prime, that angle is congruent to angle A. So angle D prime A prime C prime is congruent to angle A. But I already knew that angle A was congruent to angle B prime A prime C prime. So D prime A prime C prime is congruent to A is congruent to B prime A prime C prime. Okay? So then D prime lies on the line through A prime B prime. D prime lies on the line through A prime B prime. How do I know that? By postulate V-1. There's one and only one angle on this side of the line congruent to angle A. Probably should have said that. So I know that this angle is in fact equal to this angle. Probably should have added that line. And therefore D prime has to be on this line. That would have been a good thing to add. So then D prime lies on the line through A prime B prime by V-1. Observe that D prime lies on the line through A prime B prime. So it lies on the line through A prime B prime. And the line through B prime C prime. So it lies on the line through A prime B prime and the line through B prime C prime. And since two lines intersect at a single point, then D prime has to be equal to B prime. That's the heart of the proof. So then CB is congruent to C prime D prime, which is equal to C prime B prime. So CB is congruent to C prime B prime. Therefore, the two triangles are congruent. We showed all their angles are congruent and all their sides are congruent. Therefore, the triangles are congruent. That's a lot to take in. Any questions on that one? Good? All right. Now that we have that, our next two proofs will be really simple, and then that will get us halfway through the chapter, and we'll do the other half of the chapter next week. This chapter is it's a lot to take in. This will probably be the chapter that you have the hardest time on your homework with. Let's see if I can keep that column on. Yeah. Okay. So these next two proofs will be easier because we have side angle side now to use. So now we can use our side angle side theorem. So next one, let triangle ABC and triangle A prime B prime C prime such that angle A is congruent to angle A prime, AC is congruent to A prime C prime, and angle C is congruent to angle C prime. So the two triangles have two angles congruent to each other, and the segment joining those two angles congruent to each other, I'm going to show then the two triangles are congruent to each other. Or in other words, I'm proving your angle-side-angle congruence here. If you have an angle-side-angle congruent on two triangles, then the resulting triangles are congruent. So, I already did my let up here in the proof. So let triangle ABC and triangle A prime, B prime, C prime such that these hold. So drawing our pictures, here's A, B, C, here's A prime, B prime, C prime. And what do I know right off the bat about these two triangles? I know that this angle is congruent to this angle, this side is congruent to this side, and this angle is congruent to this angle. That's what was given right here. So in red is the information we know. Green is what I'm going to try and prove. If I can prove that this side is the same long as this side, then I know I have side, angle, side, side, angle, side, and so the two triangles are congruent using this theorem.
Oh, okay.
So it's going to be very similar to the other proof. I'm going to pick the point D prime on here. That makes this side the same big as this side, and show that D prime is in fact B prime, and we're done. So same proof idea as before. Okay. So then triangle A prime, C prime, D prime is congruent to ACB by, number one. Let D prime on B prime's side of C prime such that C prime D prime is congruent to CB. C prime D prime is congruent to CB. So now I got this triangle right here. Right? And this triangle right here is going to be congruent to this triangle. How do I know that this triangle using D prime is congruent to this triangle?
Because it'd be side angle side.
By side angle side. They have this side congruent to this side, this angle congruent to this angle, and this side congruent to this side.
Yeah.
So A prime, D prime, C prime is congruent to A, B, C. So then, triangle A prime, C prime, D prime, order here matters, is congruent to triangle ACB by side, angle, side, side, angle, side. Make sense so far?
Yeah.
Order there, very important. Okay, so if this triangle, the one using the green line, is congruent to this triangle, then obviously their angles are congruent. So then angle angle D prime A prime C prime, D prime A prime C prime, has to be congruent to angle BAC, because these two triangles are congruent. But, so D prime A prime C prime, its angle, has to be congruent to angle A, but I already know that angle A is congruent to B prime A prime C prime. Right? So, probably should have added as a line in here. So, angle, let's see, what letter do we use first? So, angle D prime, A prime, C prime is in fact equal to angle B prime, A prime, C prime. Because there is one and only one angle on this side of this line congruent to this angle. How do I know that there's one and only one angle? I mean, I guess we never argued that none of these angles are straight angles, so we're being a bit fast and loose here. But we'll take for granted that they're not straight angles. Okay, so then D prime must lie on the line through A prime B prime. So then D prime lies on the line through A prime B prime. Since D prime lies on the line through C prime B prime, and since two lines intersect at a single point, then D prime has to be equal to B prime. Same thinking as we used over there. So, since D prime is in fact B prime, since those are the same points, now I know that this side is congruent to this side. So now I know AC is congruent to A prime C prime, angle C is congruent to angle C prime, and I know that C prime B prime is congruent to CB. And so by side, angle, side, these two triangles are congruent. Therefore, triangle ABC is congruent to A prime, B prime, C prime by side, angle, side. I have shown that AB is congruent to A prime, B prime. Which angle did I do? Oh, sorry, we didn't do AB. We did AC. I showed AC. If I have A and C here, I better have A prime and C prime there if that's why I showed are congruent. And I showed angle C was congruent to angle C prime, so those better show up in the same place. And I showed that CB was congruent to C prime, B prime. Those better show up in the same place. And so we get that those two triangles are congruent. And so now you have your side angle side, or your angle side angle congruency theorem. Good? All right. Let's see if you got one more in you. One more nice simple proof. If two angles in a triangle are congruent, so are the sides opposite the angles. So if I have some triangle here, and I know that this angle is congruent to this angle, I'm trying to prove that this side is congruent to this side. So purple is what I'm trying to prove. Or in other words, I'm trying to prove it's a isosceles triangle.
Isn't that very similar to 6-3?
6-3. What did we prove in 6-3?
Hey.
We showed that if it's an isosceles triangle, then its base angles are congruent. Now we're going to show if the base angles are congruent, it is in fact an isosceles triangle.
Isn't that given?
No.
Oh. Okay.
So we've only shown the implication one way. Now we're showing it the other way. Okay. So let triangle ABC such that angle A is congruent to angle C. Right? Now observe that AC is congruent to CA.
Yeah.
How do I know that AC is congruent to CA?
Reflexivity.
The reflexive property. They're the same segment. Okay. So now, since angle A is congruent to angle C, angle A is congruent to angle C, and AC is congruent to CA, and angle C is congruent to angle A, then I know triangle ACB is congruent to triangle CAB.
Yeah.
I showed A is congruent to C, AC is congruent to CA, and C is congruent to A.
So okay.
So triangle ACB is congruent to triangle CAB. It's just relabeling the same triangle twice. It's what we did over here. I just didn't split it up and draw it as two separate pictures. So, since the triangles are congruent, then their associated sides are congruent. So now I know side AB is congruent to CB. So now I know AB is congruent to CB. Good? All right.
Is that something that we do often? Relabeling the same triangle?
It's a common trick. Shows up a lot.
That makes sense.
Thinking about the same triangle two separate ways. Anything else? Think you're good? All right. Note of warning on your homework. I think it's exercise group 6-5. So when you're doing exercise group 6-5, it's going to have you state with two triangles which angles are congruent to which, or prove that this angle is congruent to that angle in two separate triangles. When you're doing this exercise group, you do not have the side angle side theorem. You only have the side angle side postulate. So be careful when you're doing your homework that you're only using theorems as they're introduced. So since these theorems are proved after exercise group 6-5, you cannot use them in doing exercise group 6-5. Exercise group 6-5 is focused on getting you comfortable using this postulate. And so exercise group 6-5 is going to do over and over again. It's going to give you some pictures of triangles in different orientations, something like this. And it's going to tell you something like, you know that this side is congruent to this side, you know that this side is congruent to this side, and you know that this angle is congruent to this angle. prove that this angle is congruent to this angle. It's going to have you do something like that. And you're going to get that for free from side angle side postulate. Stuff like that.
Okay.
Make sense?
Yep.
Okay. So you can take break, and then the rest of the class you get for starting on your homework. I'm going to stop this.